everyone, my name is Shruti malpure. Today I am going to present the research paper activity and my topic is Understanding IoT System, a Life Cycle Approach. Second slide is outline. In this slide I have used the contents which I mentioned in the PPT. First one is introduction. To build a robust and effective IoT system, one has to initially derive the right architecture requirements of the system. The life cycle view is particularly important in architecting IoT system due to many collaborating elements involved, each with its own unique life cycle. The life cycle views helps to identify the non-obvious problems entailed in the system life cycle. The generic lifecycle model for IoT by observing IoT lifecycle of existing IoT solution including AWS IoT, works with Nest, Apple HomeKit, Philips Hue and open architecture for intelligent solid-state lighting systems. The universality of the generalized life cycle by evaluating how existing IoT solution instantiate this life cycle. The first figure shows the user interface with its system through the IoT application. An IoT application is established by collaborating with IoT services. The IoT services and applications are delivered by software components, that is, services and application components that are beside the IoT device and IoT device host and run system components that are used by both services and application components to perform the system related task. A system component also manages, that is, install, start, stop, uninstalls services and application components. The second figure shows the system components in IoT service, which includes management, security, discovery, access, and networking components. The management component manage the services and application and also monitor the system. Other system components are used by services and application to enforce security, discover, publish, and access service to communicate with other nodes and the networks. The second slide is the generic lifecycle model for the IoT. There are three main elements in an IoT system. First one is IoT device, second is IoT service, and third one is IoT application. The generic life cycle for IoT represents the stage of the above element go through from constructions to destructions. The first is generic life cycle for IoT devices. An IoT device hosts software components that are categorized into system, service, and application components. The stage in the IoT device are reconstructions, production, installation, and commissioning, operate, update, and decommissioning. The reconstruction stage pertains to the construction of the device hardware and its initial software and to the reconstruction of the device firmware and initial software. Both of these activities should follow the common product development life cycle of the specification, design, implementation, testing to ensure the functional appropriateness. The production stage pertains to the large-scale production of the device. It performs the manufacturing the hardware device, deployment of the software, and also the mass deployment of the cryptographic material. The installation and commissioning stage performs the device for operation and secure communication within the network. During this stage, it plays a role in achieving functional appropriateness and the security. The operation stage supports the execution of the IoT service and application by running relevant system components. The performance of this system depends on how well these system components perform their function. The device goes into the update stage when it needs to run management function for updating the device. All these updates should be done via the network, as IoT system typically consist of a high number of devices and distributed in remote place. The last stage of the generic life cycle is decommissioning. Allowing the device to perform decommissioning properly will help usability and adaptability. The second is generic life cycle for IoT service. A service is contractually specified overall functionality of the entity. IoT service is used by IoT application to achieve their goals. The stage of the IoT services are reconstruction, deployment, execution, reconfiguration, and termination. The reconstruction stage pertains to the construction and reconstruction of the service component for commissioning the device. Both construction and reconstruction follows the common software deployment lifecycle of specification, design, implementation, and testing to ensure functional appropriateness. When a service is ready to install and it goes to deployment stage, the goal of this stage is realize service deployment via the network. As once IoT devices are installed and commissioned, the physical deployment is no more feasible due to their high number and remote placement. The next stage is execution. The goal of this stage is enable to the service and to be used by the growing number of the application and other services while matching the acceptable performance. The reconfiguration stage allows the service parameter to be adjusted via the network. A proper implementation of this stage helps to modify modifiability, as service parameter can be adjusted during runtime. The last stage of the service life cycle is termination. The proper termination of the services is important for maintaining adaptability of the system, as removal of the service from the system needs to be detected quickly. And third element is generic life cycle for IoT application. The IoT application provides abstraction for the users from the networks and platform. Detail of an otherwise very complex IoT system. Application development in the reconstruction stage should therefore be a simplified process of software development. It entails stretching available service to fulfill a desired goal. The next stage is deployment. The deployment stage entails generating application components, distributing components via the network, installing the components to target service, and starting the component. Once deployed, the IoT application goes into execution stage. At this point, the application is ready to perform the expected behavior. During the execution, the application can also be switched on and off. User experience the behaviors and functionalities that they expected from the application while execution. Therefore, proper installation of this stage is important for achieving functional appropriateness. The reconfiguration stage allows user to adjust the application parameter via the network. The proper realization of this stage will improve the usability and modifiability. The last stage is termination. In this stage, application should stop accessing service, stop the execution, and remove itself from the host device. A proper realization of this termination activities helps adaptability, as the system can recognize the application removal in the timely manner and synchronize its state accordingly. In this slide, I have concluded the research paper. The generic the conclusion of this paper is the generic life cycle for IoT device, IoT service, and IoT application provides the better understanding for the problems that we need to be solved by IoT system throughout their life cycle. The generic life cycle for IoT can help system architect specify and design robust and effective IoT system. Acknowledgement of this paper is this research was performed within the framework of the strategic joint research program on intelligent lightning between TU or E and Philips Lightning B.V. In this slide, I have made the list of few reference paper which we used in this research research activity. Thank you.